Welcome to a world where the ordinary becomes extraordinary. A world where elements unite and separate, where reactions occur, and where properties define the very essence of matter. Today we journey into the fascinating realm of metals and non-metals, exploring their physical and chemical properties. So buckle up. It's time to delve into the heart of chemistry. Imagine the strength of iron, the lightness of aluminum, the luster of silver, and the conductivity of copper. These are all metals, elements that share common physical properties. They are hard, shiny, good conductors of heat and electricity, and can be hammered into sheets or drawn into wires. But remember, there are exceptions. For instance, sodium and potassium, though metals, are so soft you could cut them with a knife. Now visualize sulfur's yellow crystals, iodine's purple vapors, and the dull appearance of carbon. These are non-metals, a group of elements that are generally brittle, lack luster, and are poor conductors of heat and electricity. However, they too have their unique members. Take iodine, for example, a non-metal that is lustrous, or bromine, which is liquid at room temperature. And then we have gallium and cesium, metals with such low melting points they can turn into liquid in your hand. Transitioning from the physical to the chemical, metals and non-metals interact with their environment in different ways. When metals react with oxygen, they form metal oxides. Iron, for example, combines with oxygen to form iron oxide, more commonly known as rust. These reactions can be represented by chemical equations such as 2Fe plus 3O2, 2Fe2O3. Some metals like aluminum and zinc form what we call amphoteric oxides. These oxides can react with both acids and bases, showcasing their dual nature. Likewise, metals react with water, though the intensity varies. Some, like potassium, react violently, while others, like iron, hardly react at all. Metals also react with acids, producing salt and hydrogen gas. Take sodium, for example, which reacts with hydrochloric acid to produce sodium chloride and hydrogen. This reaction can be represented as 2Na plus 2HCl, 2NaCl plus H2. However, not all metals react with other salt solutions. For instance, copper does not react with sodium chloride solution, indicating its lower reactivity. In contrast, non-metals react with oxygen to form non-metal oxides. Sulfur, for example, reacts with oxygen to form sulfur dioxide. Non-metals also react with bases and acids, but their reactions differ from those of metals. In conclusion, metals and non-metals, with their unique physical and chemical properties, are the building blocks of our universe. They react with oxygen, water, acids, and other salt solutions, forming various compounds. And while they share common properties within their groups, they also have exceptions that make them unique. So the next time you look at a piece of iron or a chunk of sulfur, remember, there's more to these elements than meets the eye.